Algebra 1, Chapter 1, Section 5, Equations. A mathematical statement that contains an algebraic expression and symbols is called an open sentence. So, something like 2x plus 3. It's an open sentence. It's there. It's not a complete thought or idea. Well, it's a complete thought, but there's really no relationship to it all. So when we throw in an equal sign, like equals 8, it turns it into equation. And now there's some sort of relationship that we have between the two different expressions. You notice so far with all of the expressions that we've been working on in the videos, I haven't used many equal signs. Maybe occasionally I've used an equals with an arrow, so that just means, hey, the next step is equivalent, or I've probably just used mostly normal arrows. I didn't use the equal sign a lot because we weren't really working with equations and we weren't really solving equations. We were just manipulating and evaluating expressions. Too often people think that the equal sign is an operator, but it's really about a relationship here. These two expressions, 2x plus 3 and 8, are equal to each other. It's powerful. They are the same thing. Okay? The solution is the values of the variables in it that make the statement true. So whatever makes that equation true for x is what the solution is. And the last problem, x equals 2.5. Another relationship between two things, the variable x and the value 2.5, they are equal to each other, they are the same. That value makes the previous equation true. 2 times 2.5 is 5, plus 3 is 8. That's what we're all about here. So let me highlight there that the solution makes the sentence true. If it's not making it true, then it's not the solution. Now, it still might be an interesting thing to think about, but it is not the solution to the equation. One thing that we use a lot, pardon me, I've been talking a lot today, a replacement set is a collection of values that might have the solution in it. In the very beginning, you just test each value and see what it is. And this is before you learn how to solve equations. Now, some people might already know how to solve equations. Maybe you took algebra before, maybe you took pre-algebra and you talked about solving equations there. But the skill of using a replacement set is important, and it's something that we need to practice. And I'll kind of show you why in one of the examples. But you see things like 1, 2, 3, 4, 5, just a list of numbers in a set. And that's what a replacement set is. The solution may be in there, it may not be in there. Each one of the numbers inside of it are called elements. Like 2 is an element of the replacement set. And so we're just trying to find any of those elements that make the statement true, and those will become our solutions. So, example 1, use a replacement set. We're going to find the solution set of the equation of 2p plus 5 equals 13 if the replacement set is 2, 3, 5, 4, and 6. Now what's happening here is I've got all of these numbers, 2, 3, 4, 5, and 6. These are all potential solutions to the equation 2p plus 5 equals 13. So what I'm going to do is, one at a time, plug those in and evaluate the expressions that I have until I can see whether I have a true or false statement. So, one thing I'd like to do here is just to make a big table. What if I'm using the replacement number 2? I'm going to call that column P, because that is one of the numbers in the replacement set. And I plug it in here, 2 times the p-value of 2 plus 5 equals 13. And what do I get from that? Notice how I forgot my 1 for 13. Notice how I'm not using another equal sign here. I'm using an arrow to say, now I've evaluated everything. 2 times 2 is 4, plus 5 is 9. Does 9 equal 13? No, it does not. So that is not a solution. So I'm going to put a little x next to that and say that it's not equal. If you don't like the little arrow thing to go to it, just make a third column. All right? And that's what I'll do for the rest of them. Now let's try 3, the next replacement set element. 2 times 3 plus 5 equals 13. 2 times 3 is 6 plus 5 is 11. Does that equal 13? No, it does not. So 3 is not a solution. 4, 2 times 4 plus 5 equals 13. 2 times 4 is 8. Plus 5 is 13 equals 13. Is that a solution? Yes, it is. So 4 is going to be in my solution set. Onwards. 5. 2 times 5 plus 5 equals 13. And I find there that 10 plus 5 is 15. Does that equal 13? No, it does not. So 5 is not in the solution set. And now the last one is 6. 2 times 6. If you want to take a second and predict, do you think it's going to work? Looks like it didn't. So it's not a solution. So 6 is not a solution. So what I'm looking for now is trying to write down the solution set. And I do that by writing down a little bracket, just like the replacement set came in. And the one value that happened to work here was 4. So that is my solution set. Lots of times we just write P equals 4 or something like that. But when it's asking for a solution set, you have to have it written in set notation like this. So what are one of the values of doing problems this way? Well, on a lot of standardized tests, they give you an equation and tell you to solve it, and then they give you 4 possible answers for it. So all you have to do is plug them in and see which ones of them make it true, because that's going to be the solution. So I'm just going to do it underneath each one of them. 6 plus 5 squared minus 5 divided by 2 equals 3. Well, now I just need to simplify all the stuff. 5 squared is 25 minus 5. I'm going to divide that by 2 eventually, then add 6. I want to check if that equals 3. 20 divided by 2 is 10. 6 plus 10 equals 3. Does 16 equal 3? No, it does not. So that is not a solution. Now, one nice thing here is I notice that all of this stuff here on the left-hand side does not have a variable in it. So when I do this again on the next problem, 6 plus 5 squared minus 5 divided by 2 equals 6. I get the same stuff. 6 plus 25 minus 5 divided by 2 equals 6. Then I get 6. 25 minus 5 is 20 again, divided by 2 again. I get 10, and I get 6. 16 does not equal 6 either. Now, if you notice what's happening here is on the left-hand side, it's always going to be 16. Well, guess what the last answer is? 16. I should plug it in to double check. 6 plus 5 squared minus 5 divided by 2 equals 16. 6 plus 25 minus 5 divided by 2 equals 16. 6 plus 10 equals 16. Yes, 16 equals 16. That one checked out. So here my answer is P equals 16. All right. More information in the next video. Sorry, I'll show you what the last little bit I wrote there. More information in the next video.